Hey class, let's go over Module 1 review. So we have, which of the following number represents 6,910,152,824? So using our big numbers skills, we kind of have, so my billions is blue. So we have 6, oops, I want this bigger. There we go. 6 billion. Millions are green. So we have 910. Thousands are red, and ones are kind of just plain. So looking at all these numbers, these are the ones digits because they're the first set of 3. And we need it to be 824, and they're all 824. So that's not going to be determined. Now the thousand number is 152 in the thousand digit. 152, 1050. This one here does not have, it's 052, 052. So both these guys are now out because they failed that bit of the number. So the next number was our millions, 910. So that's 910 in the millions. So that's the next set of 3, 910, 910, 910. So now those are all still sort of working well. And the last one is in blue, we have 6 billion. So that's just a 6. So in the billions, we have a 6. Here, this is 600, and that's 0. So, this is not 6, and this is not 6. So that's where it fails. And if we had trillions, this is 6 trillion. So our answer would be that one right there. So, for explaining this, you could just say, this is big number skills. And then write out the number. Oh, you took the number. So we had 6,910,152,824. Then compare. Question 2. Select the number, word combination that best estimates the following number. So again, I'm going to sort of go with figuring out what is this number. So I have my ones digits, my thousands, that's supposed to be red, my thousands digits, my millions digit, my billions digit, and my trillions digit. So, and I can see all these answers are 7. So if I was dealing with rounding, I'm rounding to just these 2 digits, and this is plus 1. So my rounded number is 2, 700. And then I have 1, 2, 3 sets of zeros. 1, 2, 3, 1, 2, 3, 1, 2, 3. And I can just make sure with using my big number skills, there's the ones, thousands, millions, billions, and trillions. So how do I interpret this number? So I have a couple different ways of doing it. I'm going to get a listen. So this is true. This could be 2. I need a little thicker than that. So 2's in trillions. So this could be 2.7 trillion. Or I can go this many, and it's billions, because I'm left with 3 sets of zeros. So I have 2,700 billion. And then I could look at it this one, where I'm all these numbers, and what's left are billions. So then I also have 2,700,000 millions. And the last case is going up to here. So we have 2700, 000, 000, and the last set of units that are left are the thousands. So I now need sort of to compare. 2.7 trillion is accurate right there. The millions, I need an extra 3 zeros. It's definitely not that. We need an extra 0 with the billions. So that one's wrong, and 2.7 is also wrong. Given the following number, and again, we can analyze this as so it's 126,500,000 and 0 ones. We didn't need to read it, but anyway, write the number in scientific notation. So I have right here, I mean, to sort of expect, this is the hundredths digit of the millions. So that one is, the ones digit is 10 to the 6th. This is 10 to the 7th. So this digit here is going to be 10 to the 8th. So I'm expecting 10 to the 8th. All right. So now let's go with how do we, so I'm going to erase this and go with the rule. So first thing I'm going to is put my bar between the first and second number, and I'm going to put the decimal point there. And then I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. I was right. So it is, so it'll be 10 to the 8th. And then I'm going to move the decimal place over to here, and I'll get 1.265 times 10 raised to the 8th. And if you're not sure that you can make sure you draw it up high, put the little caret there. So we know that that 8 is the exponent. And then write the number in words. Well, it's kind of what I did do that part. So we have, I'm okay if you write the digits 126,500,000. And it's my extra to say 0 ones. This is just me and my soapbox of believing we should acknowledge 0 units. But the main thing we're looking for is those guys. And question 4. Suppose 3 in 3,026 people have an auto accident in 10 years. Estimate the percentage of people who have an auto accident in the past 10 years. So this is data. This is time. This is time. So the numbers we really need is we have 3 out of 3,026. They're saying estimate, 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 estimate. So that means, well, I can see that get nice numbers. So I'm going to rewrite this. 3 is a nice number, but 3,036 is just 3,000. And this just equals 3 times 1 over 3 times 1,000. So I have 1 in 1,000. And you'll be like, okay. And I'm out of room. Eeks. 1 in 1,000ths. Just I'll shrink this bit. There we go. So 1 in 1,000, how do we interpret that? You could think of it as 1 over 10 times 1 over 100. And so here we can think, oh, it's a 10th of a percent, because this is the percent symbol. Or you can go, you have 1 over 1,000. We know that if it's P over 100, that is P percent. And that's what they're asking for. So you can think of, what do I have to do to 1,000? Oh, I have to divide it by 10. So I'd have to divide both by 10. And then we get 0.1 over 100. So that is 0.1%. So somehow you have to sort of come up with, and there's other ways you probably could come up with, how 1 over 1,000 is 0.1%. Question 5. Imagine you're explaining the relationship millions, billions, and trillions to someone else. You may use words, symbols, pictures to explain how you're writing rubrics. So we actually have our nice little description here of millions, billions. So you could even describe from our, like, you could say, yeah, why is my pencil? Imagine 1,000 people in a line, standing shoulder to shoulder. Sure. That would be about half a mile. I mean, we had 0.4, but that's close to half a mile long. A million is 1,000 times 1,000 people. So that'd be 1,000 times 0.5 of a mile, so 500 miles, which is about the distance between Detroit and New York City. Roughly, I don't know for sure. And then we've got, a billion is 1,000 thousandths, is 1,000 millions. So a billion people, which is 1/8 of our world. So a billion people would stand 500 times 1,000, so 500,000 miles. So 400,000 miles. Then I Googled the distance between Earth and the moon, and it is about 200,000 miles. So that's about the distance Earth to moon back to Earth, something like that. I don't think you'll have to write an essay, but that's just one problem to get used to. Some types of investment called certificates of deposits earn interest rate based on a percentage rate. People often estimate doubling time of an investment to predict how much money of an investment will be worth in the future. An investment that earns 4% interest will double in value in every 18 years. So this tells you T plus 18 value between 2 times old value. So that's kind of our model we'll have. So our year is going to be old year plus 18. Or in this case, we have to go backwards. So this will be minus 18. But here we'll go plus 18 plus 18. So 2018 and 2036. And then going backwards, we're 1982. So that's kind of how we can go about figuring out the time. We go forward plus 18 years and go back, we subtract 18 years. So this is going forward plus 18 and going back minus 18. Now doubling time, this is going 2 times old value. So, this is 2 times 2.5. And this is equal to 2 times 5. And so this last one would be 2 times 10, where the old value, 5 comes from here, comes from there, the 10 comes from there. So we can have that the value, it will be 20. And that's something else to note, because they might say the value, it's 20. Note that this is $20,000. But now the last thing, we know that this is 2 times some value. And that's going to be this question mark up here. And we don't know what it is. So we know 2.5 equals 2 times something. So we actually have to go backwards. So in going forward, we basically times by 2. So to go backwards, we have to divide by 2. So then we get 1.25 equals, and then so we can see this is 1.25. And then this is 1.25, and again, it is in thousands of dollars. So a trick they could ask, oh, what will the value be of the investment in 1954? Oh, I guess we didn't need to know the start. So there the trick is you have to say 20,000. So that's the table shenanigans. Don't forget to, especially if it's doubling time, don't forget to look at table shenanigans. Question 7. Estimate, big E. The answer to the following questions. Explain your strategy. We need 62% of 80. So I'm going to go for 62%. I'm going to go 10% strategy. 10%. 62% is about 60%, which is equal to 6 times 10%. 10% of 87 is equal to 8.7, which is about 9. And this, I might note, is an overestimate. So I have to do 6 times 9, which is equal to 54. So this is actually bigger. So, I mean, 54 is okay. At that point, you can stop, but like, you're like, well, subtract a little bit. So I might just say 52. 37 is what percent of 125? So we have this P percent equals 37 over 125, times that 100% thing. So we need to estimate 37 and 125. So, get nice numbers. I don't know if that's a strategy. So I have 37 over 125, and I can see that this is like 40, it's 120, and then that's 1/3. And then I know that that is our 33%. So, I mean, my explaining is get nice numbers, I guess, and then reduce. Which expression is the same as 20% of a billion? So we have 20% of a billion. So that is 20 over 100 times 1 followed by 9 zeros. All right, so canceling things out, I got 2 zeros here and 2 zeros there. So I can cancel those guys out, and I'm just left with 20 times this number. So we have 2 times 1, which is 2. And I have 1, 2, 3, 4, 5, 6, 7, 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. And now I add the commas. So if we're going back to my units, ones, thousands, millions. So my number is, in terms of millions, go green. So I see that this is 200 million, because that's, the 200 is the number in green. It is 200,000. So this is up to here, thousands. It is 200 million. I said the word ones. And the other one that's a little bit tricky is if, sorry, let me go back, make sure I do the, yeah, billions are blue. There's nothing here, but you can always put in more zeros in front. So the last case of this would be 0.2 billion. That would be the really sneaky one, as if they added that there. All right. So this is a billion. And it's 0.2. So this answer is correct. This is 0.2 times a million. So no, because we have 200 million. This needed to be 200. 10 to the ninth divided by 5. So this is a billion. 1, 2, 3, 1, 2, 3. Oops, I should be in blue. All divided by 5, which would be, that would also be 200 million. No, 10 to the, it'd be 10 to the 12th divided by 5. Sorry about that. Ten to the ninth. So then let me write that one. So you guys can use a calculator. I don't have a calculator. Let me rewrite this one here. So we have 10 to the ninth is a billion. So that's 10 zeros with 9 zeros. And we're dividing it by 5. So we can just focus on this little bit, 10 divided by 5, and that is a 2. And then we have 1, 2, 1, 2 zeros left. And then we have these 3 zeros and these 3 zeros. But look where the commas go. You 1, 2, 3, 1, 2, 3.
You're still teaching?
That's 200. Oh, that's 200 million. Yeah. So that is correct. This one's another winner. 10 to the ninth divided by 20. So if we did this here, we'd still have our 10 to the ninth is the billion. Three, 1, 2, 3, 1, 2, 9 zeros all over 20. So now when we're dividing by 20, we can divide this number by 20. So 100 divided by 20, and that gives us a 5, and then we're left with a 0, comma 0, 0, 0, comma 0, 0, 0. So we only get 50 million. So this is 50 mil, and it's not a correct answer. And the last one's 10 to the 6th divided by 5. Already not enough zeros. So we can just kill that one. So we had two answers. Answers 2 and 3. So another thing you could have done is multiply these out and figure out the answers and then compare it to what we had over there. Aaron owes $4,800 on his credit card. Maybe I'll go green. The annual interest on the, we have purchases. I can go lighter purple. Annual interest purchases 12.9%, and the annual interest rate for cash advance is 18%. 1/4 of his credit card is for cash advances. So that's dealing with cash advance. How much interest will Aaron pay over a 1-month period? So right here we have, no, backspace. 3/4 is for purchases. So they want to know, and then the last thing we need to point out here is 1 month period. So we need to find a whole bunch of stuff for purchases, and then we need to find a whole bunch of stuff for cash advance. So I'm going to sort of keep my data separately. So I have 3/4. I'm going to pull this guy, make this a little bigger so I can zoom in. So 3/4 is purchase. So we have 3/4 of the balance is purchases, and that is $4,800. And we have 1/4 of the purchases is for cash advance. So this is purchase, cash advance. So this equals 3,600, and this is 1,200. So that's the balance in that one. So now we have, next thing we have interest rate. The APR, the annual interest rate for purchases is 12.9%. And the annual interest rate for cash advance is 18.9%. And then we have our monthly. We're going to divide by 12. So that's a new bit. So now we have 12.9 divided by 12 and 18.9 divided by 12. And we'll get some values here. And here you kind of want to keep your calculators kind of open here. 12.9 divided by 12, and we get 1.075. And we were expecting an answer close to 1 because it's 12. 12 plus a little extra divided by 12 will be about 1. And then 18 is less than 24, so we're still expecting an answer between 1 and 2. So we have 18.9, around, I would say 1.5 or so, because it's a little more than halfway. Ooh, and we get 1.575. All right, so now we have our two answers, and that's the interest rate. So how much interest? Interest is rate times balance. So we have, now remember, this is a percent here. So we have 0.0175. There's a missing a 0 there. And then we have 0.01575 times 3,600. And here times 1,200. And we will get times, we get 18.9 there. And then we have and I think this is 38.7. And the last thing we have to do is we have to sum them. 6, carry the 1, 7, don't get the decimal place. So we would get $57.60. I mean, it's just sort of going through and realizing what you would need to answer this question. So, oops, I don't know what this is. Shoot. Oh, well, I lost my cheat sheet. Okay. Ivory College has a tuition rate of $850 per credit hour. The college plans to increase tuition. So we're increasing tuition by 4.5%. What will the new, and then this is kind of, what will the new tuition be after this answer? Give your answer as a complete sentence containing both context and quantitative. Ooh, writing principle. Writing principle. So, new tuition. So this is a percent more problem. So the new value will be old value plus P% of old value. So we need 4.5% of $85. 0.045 times 85. And we get 3.825. And this is the tuition increase. Tuition increase amount. So now we have to do 85 plus 3.825, which would be 88.825. And they probably want the answer. Well, probably to the nearest. If it was nearest cent, it'd be 0.83. If it was to the nearest dollar, it would be $89. So it depends on how they want to answer. So now we have to do the quantitative writing principle. What will tuition be after an increase? What, where, when? So college. The college plans a tuition increase. So where the college, what the tuition increase or tuition from $85 to $89. That nine's not looking very nine-ish. College plans a tuition increase rate, which is a 4.5% increase. You could also say a college plans to increase tuition by 4.5% from $85 to $89. I mean, you can practically just use, oh, I was zoomed in. I didn't have the Ivory. Okay. Ivory College. I mean, you can basically rewrite this whole sentence. Ivory College has a tuition rate increase. The college has by 4.5% to a new value of $89. Suppose that the temperature dropped 10%. So let's go, we're still, no, we got 10%, dropped 10% in a 3-hour period of time. If the temperature was 45 degrees at the beginning of the period, what is the approximate temperature at the end of a 3-hour period? So this, instead of it being a percent more, this is a percent less problem, which means old minus P% of old. So old value is 42 degrees. 10% of 42 degrees is 4.2 degrees. And then we have to do 42 minus 4.2. We get 8 with 1, 3, 11. So we have 7.8 with the 3. Did I do that? 11? Yeah. So explaining your process is percent less problem, and then the model, old minus P% of old. So after a 3-hour time, the temperature dropped by 10% from 42 degrees to 37.8 degrees Fahrenheit. Emily has a good credit and gets the lowest possible interest rate, which is 10.9% for this card. She is not able to pay her balance in full, so she pays just interest. Emily would like to pay in a year if she also estimate how much, so that's a big guy, estimate how much interest Emily would pay in a year if she kept the balance of $500. Whew, okay. So only paying interest for a year is like finding the APR of the balance. So that's one way to do it. So we need 10.9% of 5,000. And now for estimating, we're going to do nice numbers. So this is about 10% of 5,000, which is equal to $500. Using, because 10% is just moving the decimal. So another way you could go about it is, and this gives you a higher estimate, find monthly. So 10.9% divided by 12 is about 12 divided by 12. So we get 1%. Then we find 1% of 5,000. Now this is moving the decimal 2 spots, and we get 50. And that's per month. Then we're going to times that by 12 months. And we get 50 times 12, and we get 600. So those are like two possible strategies for solving, and both are valid. It depends on how you round it. And the last question before I take a break, Stephen was in first place in a contest and won $2,500. So that's Stephen. His friend Jennifer was in fourth place and won $5,000. Fill in the blank. Stephen won blank times as much as Jennifer. All right, so that's our M. So one way to set up the problem, you can think of Stephen's money equals M times Jennifer's money. And we want to solve for M. Or, we take, and then what we find is if we have Steve's number divided by Jennifer's number, that will be our M. So we can use that. So it's the M times bigger. This is our M times bigger model. And either of these setups are the same as M. So we have our 250,000, and then we have just our 5,000. And if we can remove the same number of zeros, so this problem reduces to 250 over 5. That's 5 times 50 over 5 times 1. And then I have my 5's cancel, so I get the answer of 50 times. So my number here would be 50. I'm going to